look at 51, 426. So memorizing in a memory experiment, Alan is able to memorize words at the rate in words per minute, right? It's a rate, 2 measurement units in words per minute given by m prime of t equals 2t minus 0.09 t squared. In the same memory experiment, Bonnie has m prime of t, 2t minus 0.006, no, not 2 zeros, just 1 0, t squared. Okay, so let's see what they want. Who has memorized more words after 10 minutes? And how many? So remember, we are given the rate of change. So they're telling us 0 to 10 minutes in minutes. And these are, of course, words per minute. Both, of course. So in part A, they're asking us, we do not have the memorizing function. We have the rate of change of the memorizing function. They're asking us to find how many, which one had memorized more and exactly how many over 0 to 10 minutes. So what are we asked to determine?
First, we have to find the first one and then the second one.
Sure, but just remember, this is, let's go back here for a second. No, not the last time, but this one is better. Okay, so I'm given the rate of change. If I find a definite integral, what will I find? Of course, not revenue, because this is not revenue, but I will find the total over 0 to 10, the total of what?
Words.
Exactly. Learned, memorized over that time. Awesome. So obviously we have to determine the integral from 0 to 10. I cannot write dx because the function has t, so now I have to write dt. What? What do I write in here?
2.
Yes, 2t minus 0.09 t squared. Awesome. Good, so let's continue. How do I find this? Anyone would like to help? Which function prime is 2t?
2t squared over 2?
Yes, 2t squared over 2. Minus 0.09. Which function prime is t squared? Very good. Luckily, I don't have to plug in 0 because this will be 0 and this will be 0. I simplify these two. So I only need to plug in 10. So this is 100 minus. I'll simplify here by 3 and I get 0.03. And 100 to the third power. I'm sorry, 10 to the third power, 3 zeros. Okay. I don't need parentheses, but I wrote them anyway. So I'm moving the decimal point 3 units to the right. 1, 2, 3. So 100 minus 30. What is that?
70.
And this is words. So we can repeat for, and we have to repeat for Bonnie. So for Bonnie, we have the integral from 0 to 10 from 2t minus 0.06 t squared, of course, dt. And I know you're going to say the same thing, 2t squared over 2 minus 0.06 t to the third over 3, and from 0 to 10. Simplified, 10 squared, again 100, minus, this is 0.02, and to the third, again, is 1,000. So this is 100 minus 1, 2, 3, minus 20, which is 80 words. So I know it's a silly question, but which one is bigger? I know you don't have to answer that. So obviously this. Good. So that was part A. They were asking who has memorized more words after 10 minutes. It appears that Bonnie. How many more words? How many more? Well, 10 more. 10 more words, right? So the difference is 10 more words. Part B, over the first 10 minutes of the experiment, on average, the word on average is really exactly what this means, right? On average. What was, on average, how many words per minute did Alan memorize? And over the first 10 minutes of the experiment, on average, how many words per minute did Bonnie memorize? We already calculated. Let me go back to the previous page. We already calculated this. We calculated this for Alan, and we calculated this for Bonnie. They're asking us only to do what in part B and C?
It's going to be 1 over 10.
Exactly. So we have 70 divided by 10. That's all we need. So this is 70, and this is 1 over 10 minus 0. So 70 divided by 10. So that is 7 words per minute. And what about for Bonnie? So this is for Alan. What about for Bonnie? How many she memorized per minute?
8.
Yes. So this is 80 over 10, which is 8, of course, words per minute. So this is how we use the formula for the average value of a function. Okay, let's look at one more to have another type of example. Let's say accumulated sales. So the Music Manager Ltd estimates the monthly revenue in thousands of dollars. So R of T, don't forget to write thousands. So we don't forget the measurement unit. Attributable to its website, fine. T months, so T is in months. So I don't forget. Launch, okay, so it's given. So we have R of T, which is 0.5 E to T. Okay, find the average monthly revenue attributable to the site for the first 4 months of the operation. How do we find this?
By using the formula of average?
Yes, indeed. Our average is. Can anyone dictate how we write it?
One over 4, definite article 0 to 4, 0.5 e to the t dx.
Yes. However, if the function is given in t, we have to write t, dt. Perfect. Awesome. So I will move 0.5 outside. So 0.5 over 4. And now I'm asking myself, which function prime is e to t? This is out. Which function prime is e to t? And this is always the easiest.
E to t.
Exactly. Careful now. In such a function, plugging in 0 will not give us 0. So do not assume for such a function that you plug in 0. For polynomials, it works. Okay? So we have 0.5 over 4. We plug in 4. We get e to the 4th. But minus, when I plug in 0, what do I get? E to 0 is
1.
That's it. So since it doesn't make any sense without an approximation, I am going to approximate it. Here it is. So we have, don't forget parentheses for the first piece, because the calculator will not do what you want. So in front, I have 0.5 divided by 4, and now in parentheses, e to the 4th power, e to the 4th power, and then minus 1. So we got 6.7 approximately. Now we have to identify the measurement unit. So let's go back. Okay. Find the average monthly revenue attributable to, okay, so
It's in thousands.
Thousands of dollars. Okay, so then I can write $6,700. Good, awesome. Do we have, are we in the clear with finding the average value of a function, the formula? Are we okay with that? Yes, no, anyone? I'm assuming you said yes, although I didn't hear anyone. So we have many techniques of integration. I meant to write CT. Never mind. I'm going to write it again and erase it from there. So techniques of integration. We have many. However, in this class, we are only going to talk about 1 and 2. This is what we already did. Simple. What's simple? This is simple. I was able to find the antiderivative very easy. Simple. Everything was simple here. This function prime is this. This function prime is this. This function prime is this. So that's the simple one. The second technique of integration is something called substitution. And this is section 4.5 and the last section of chapter 4 that we are going to look at. I like to present this as easy as possible. And you'll tell me whether it's clear or not. We're going to work through all the problems that we can for the rest of the class today. And I'll explain how and why we do what we do. Of course, we're going to look at two different situations for indefinite and definite integrals. Let's start with indefinite. And we are on page 434. 434. And I know you probably know nothing about it so far, unless you went ahead. That's fine too. But I would like you to choose. So we are looking at indefinite. So far, as you see, from 1 to 44, they're all indefinite. And for 45 on, they are all definite. So let's take it slowly. And I'll explain step by step the procedure.
Maybe number 3.
Let's start with number 3. Awesome. So 3 on 434, and this is my page 6. Let's see how I am with time here. Still good. Okay. So we have the integral from x squared minus 6 to the 7th power. And as you see, it's hidden in there, times x times dx. Okay, so you will say, it's not a big deal. You have to take this function, this binomial, to the 7th power. Then you will distribute x to it, and then you will integrate. No. Too difficult. Too hard. Because we have something called the substitution method. Substitution method, okay. Now, how do I look at this function? How do I decide what to substitute and how? So here's how I will recommend first. I'm going to look at the function, forget about the integral, forget about dx for a minute. This is our function. So this is the integral from f of x dx. So let's look at this function. by looking at this, by inspection, which part of this is difficult to work with? Is it the x, or is it the x squared minus 6 to the 7th power? Which one of these two is hard to work with? I know it's a silly question, but I'm trying to build step by step the procedure. So I know you're going to say x squared minus 6 to the 7th power, right? Are we in agreement with that?
Yeah.
Perfect. So let's say, give me a letter, any letter you want, but not x. You cannot use x.
U.
Which one?
U.
You said u?
Yes.
Perfect. Let u be this piece. So I want to change the integral from an integral with x into an integral with du. Because if I can't have x and u in the same integral. So I want all this to be converted into something with u, du. So my first thought is I have to find du. Can anyone tell us how to find du? And before you say anything, we found dey here, or du, right? We know how to find any d something, right? So, can anyone give us du for this function?
X cubed.
Careful,
over
careful.
3.
I know it's confusing. We are differentiating, right? Careful. We are not integrating yet. We want to find this. In order to find this, we have to use this procedure. We're not integrating yet.
Is it 2x?
Careful. It's the differential, not the derivative. Remember the difference between the two.
Yeah.
Dx. Perfect. Now let's see if we have this here. Yes, I have x. Yes, I have dx. I don't have the 2. Not a big deal. I can multiply by 2 and divide by 2. It's a number, it's a factor. 1/2 times 2 is still 1. But now look what happens here. All this is du. I have a 1/2 in front. I have the du. What does this become? And I'll put it here.
Just u to the 7th.
U to the 7th power. So I changed from an ugly integral with something to this binomial to the 7th power times x, huge, difficult to come up with, into this. So I realized that this is my problem. I denoted it by u. I have to find a du, which means du equals 2x dx. Then I'm looking for it in my integral, in the original integral. Yes, I have it. A little 2 can always be made up. I multiply by 2 and divide by 2. I didn't change anything. But now 2 and x and dx are right here. The 1/2 stays outside, and this piece becomes u to the 7. Then we continue. Now we are asking which function prime is u to the 7th. Yes, now we are integrating. Which function prime is u to the 7th?
It's u to 8 divided.
Plus a constant c. So this is 1/16. I have to go back to the substitution. I have to replace now u. By what am I replacing it?
Our x squared plus negative 6.
That's it. And this is the final answer. It maybe is the first example. It may be a little bit confusing. Don't worry about it. We're going to continue for the next half an hour with any example you want, any problem you want.